This tutorial is for T9 Graph Parabolas, Algebra 2. Number 1, y equals x squared. First, you should recognize this as the parent graph of a parabola, and I want to show you two different ways you can get at your correct answer. So since there's no h or k, we know that the vertex is located at the origin, so 0, 0. One way you can think about this is pick a number and plug it in for x, and then solve for y. So if I plug in a 1 for x, that means when x is 1, what is y? So if I plug in 1 for x, I get y equals 1 squared. 1 times 1 is 1, so y equals 1. So I need 2 points to plot a graph. I already have my vertex at 0, 0. A second point I could use is 1, 1. As you're doing your homework on IXL, it will automatically fill in the parabola for you. So if I put a dot here at 1, 1, the rest of the parabola will automatically be drawn. If you were drawing this by hand, you would remember that if this is the axis of symmetry, if you have 1, 1 on this side, you would have negative 1, 1 on this side because it's a mirror image. You have that symmetry going on. All right. For the second one, I'm going to show you a different way to get at your answer, and then we're going to continue like this for the rest of our sample problems. Again, you can use either one of these methods to solve it. I just think you're going to like this way a little bit better, and I think it's a little bit faster. So for number 2, our equation is y equals negative 5x squared. I don't see an h or a k, so I know my vertex is located at the origin, 0, 0. Now, this a value that we've been playing with for the last, I don't know how many sections, right here it's a negative 5. When we were graphing equations of lines, we had m as our slope. So if you remember, y equals mx plus b was our slope-intercept form for a line. So we would plot a point and then we would use our slope, and I'm going to cover this up for just a second. And so if our slope was negative 5, we would go down 5 and over 1, down 5 and over 1 to plot our line. So the same is going to be true for this. This is a dilation factor is what it's called, but it's kind of like a slope, but you just have to remember it's happening on both sides of this parabola, right? So if we plot our first point at the vertex, the origin 0, 0, then this negative 5 from there is going to tell us to go down 5 and over 1, right? So since it's negative, it makes sense that our parabola opens down. So we would go down 5 and over 1. So down 5 over 1. Again, if you have this on IXL, it's going to automatically fill in the rest of that parabola. But if you were trying to graph it yourself, you go down 5 and to the right 1 and put a point, down 5 from the vertex and left 1 and put a point, and that would help you graph your parabola by hand. So again, you can fill in a point like x equals 1 to solve for y to find another point that this parabola passes through, or you can just treat this dilation factor as kind of like a slope to find your next point. So either way. Number 3, y equals 8x squared. So I see no h or k, so my vertex once again is at the origin. Then this time I have a positive 8, so I know my parabola opens up. If we treat this like slope from our vertex, we're going to go up 8 and over 1, and that's going to give us our parabola. Number 4, x equals 2y squared. Now the first thing you need to notice here is this is an x equals instead of a y equals. So that tells us that our parabola is going to open either to the left or to the right. We see that this 2 is positive, so our parabola will open to the right. We don't see an h or a k, so they must be zeros. So our vertex is located at the origin, and even though it feels weird to think of this like a slope, if it's positive, we're going to go 1, 2 to the right, and then down 1, and then if you were plotting by hand, go back and go 1, 2 to the right, and up 1, and that would give you your next 2 points to plot your parabola. So this was a left or right opening parabola because it's x equals, then it was right opening because our a is positive. I have one more page of examples for you, 3 or 4 more, and that's it. Number 5 asks us to graph x equals negative 4y squared. Again, there's no h or k, so our vertex must be located at the origin, so we plot that point first. Since this is x equals, it's either going to open to the left or to the right. We check to see that this 4 is negative, so that means it opens to the left. So that a value, which we're treating kind of like a slope, again it's called a dilation factor, but if that helps you kind of think how you're using it, that means that you're going to go left 4 and up 1. So left 4 and up 1. If you're plotting by hand, you would also go left 4 and down 1 to give you both sides of that parabola. Number 6, x equals 7y squared. Another x equals, so left or right opening parabola. We see no h or k, so we also have a vertex at the origin for this problem. That positive 7 tells us the parabola opens to the right, so we will go to the right 7 and then up 1, to the right 7 and down 1, because that 7 is understood to be over a 1. So just like slope, you would have 7, 1. Number 7, y equals 4 times x minus 5 squared. So this is the first time we've actually got an h. So we use that negative 5, but we flip the sign, right? So 5, and then there was not a k, so 0. So 5, 0. So here is our graph. We're going to plot our vertex at 5, 0. Then we're going to look at this 4 here, which is going to tell us that our y told us that our graph is opening either up or down. Parabola opens up because this is positive. So we will go from our vertex, we will go up 4 and over 1. Boom. The last one, x equals 2 times y minus 6 squared. We use that 6 to get our vertex. Since this is an x equals, that means this is our y value, but we have to flip the sign. We had no h value, so it's 0. It is either a left or right opening parabola because it starts with x equals. Since this is positive, it's going to be opening to the right. And then we use our 2 from our vertex to go to the right 2 and up 1, to the right 2 and down 1. And that's how we would plot those parabolas from the equation.